Here we want to find the exact value in radians of these inverse trig functions. The first one, we have the inverse tangent of 1 over square root 3. So remember our restriction for inverse tangent, we need to get out an angle that is on the right half of the circle between negative pi halves and pi halves. Since this is positive, I know I'm in quadrant 1. And if I think of the angle in quadrant 1 right here, this would be where cosine is square root 3 over 2 and sine is 1/2, and we know tangent is sine, which is 1/2, over cosine, which is square root 3 over 2. And when I take that and I flip it over to multiply it, 2 over square root 3, the 2's cancel and I do get 1 over square root 3. So we know this one is pi sixths. Looking over to the right, we have arc cotangent of 0. So it means I took the cotangent of some angle, and we know cotangent is going to be the upper half of the circle, but leaving out the two ends where it's undefined. Cosine over sine. So when is the cosine 0? And we know that that is right up here at pi over 2. So if we did cosine of pi over 2 over sine of pi over 2, that's cotangent, and we know cosine is 0 and sine of pi over 2 is 1, so we're good, pi over 2. Looking down at this next one, we have the arctangent of -1, so it's asking us, but remember our restriction, it's asking for an angle between negative pi halves and pi halves, that's for tangent, where we get a -1. So we know we're down here in quadrant 4, so that we're at a multiple of pi fourths where they're square root 2 over 2's, but one of them's negative and one of them's positive. In this case, the sine of square root 2 over 2 is negative and the cosine is positive, and so when we take the ratio of those, we will get -1. But remember, I wouldn't list that as a positive angle. I have to list that as a negative angle. That's going to be negative pi fourths. If you listed the coterminal angle of 7 pi fourths, you would get that incorrect, because remember our restricted range, what we need to get out of this arctan is something from negative pi halves to pi halves. Okay, looking over at the next one, we have the inverse cotangent is -1. So cotangent is going to be the upper half between 0 and pi, but leaving off our ends. And so because it's negative, I know I need to be over here at a multiple of pi fourths, but in quadrant 2. And so that is going to be 3 pi fourths. Looking at the next one, we have arcsecant is -2 over square root of 3. So that means arc cosine is going to be negative square root 3 over 2. So we need to think of the upper half of the circle, and we know for secant we leave out that middle, and we need something between 0 and pi. Because this is negative, we know we're over here in quadrant 2, and we need cosine, so that's the bigger one, so that's going to be right there at 5 pi over 6. Since the cosine of 5 pi over 6 is negative square root 3 over 2, so the secant there is the reciprocal of that. Okay, let's look at the next one. We've got arc cosecant, and so we know that the arc cosecant has the same restrictions as sine, so the right half of the circle, except there's going to be a hole in the middle where it's undefined. Now to get negative square root 2, to get negative, we must be in quadrant 4, and we are actually right here at the multiple of pi fourths, because if we did the reciprocal of that, that's -1 over square root 2, and if you rationalize that, that is our recognizable, what we're used to seeing, which is negative square root 2 over 2. So -1 over square root 2 is the same as negative square root 2 over 2. So I know I'm at that multiple of pi fourths, but we know our restriction, we need to give in the range from negative pi halves to pi halves, so I need to list that as negative pi fourths. We've got an inverse secant, so I'm going to think of inverse cosine of negative 1/2. And so I'm going to look on the upper half between 0 and pi, but of course with that hole in the middle for the secant. And so thinking of where the cosine and the secant are negative, that would be in quadrant 2. And that would be right here in quadrant 2 where we had a negative 1/2 for the x. So that is going to be at 2 pi thirds. And looking at the last one, when is cosecant negative 1? Well, that's the reciprocal for sine. So let's think of sine. Sine is right here. And that would include a hole in the middle, but includes the ends. The sine is negative 1 down here at negative pi over 2, to put it in the correct range. And we know the cosecant at negative pi over 2 then is also negative 1. So this is negative pi over 2.